Today we're going to turn this into this. So let's talk about some of the materials that we're going to be working with. I've got a QO single phase 200 amp panel. This is a main breaker panel, just meaning there's already a breaker in it. And I'm using all of the arc fault breakers, dual function breakers. I've got some regular 20s, and then these are all GFI breakers for 2-pole. So this is a 2-pole 60, 2-pole 50, 2-pole 40, but they're all ground fault. And then I've got a surge protector inside of here as well. I love these surge protectors because there's no wires. You literally just pop this thing in, pop it out. You'll notice that there's pigtails on these ground fault breakers. There's no pigtails on these, and I like this style better because it's just less wires to deal with. This is a plug-on neutral system, so you'll notice that there's actually a bar here, and that connects up to our neutral. So when you put these breakers in, they already make a connection to neutral, so you don't have to run pigtails up there. Now, the other style of arc fault that people have been used to using for so long are these, but you can see how far over that breaker sticks. And I just like having more compact breakers. So this is still plug-on neutral. It doesn't have a pigtail, but it just limits your amount of space. So if you start having a whole bunch of home runs coming in here and you have bigger breakers, then you run out of space. So I like, personally, this new style, different handle. Now, the next thing to talk about for all of you newbies out there is the type of wire. So this is NM cable. It's non-metallic sheath cable. We call it Romex out in the field. This is also called Romex. It's just non-metallic sheath cable, but it's bigger conductors. So I've got number 6 and number 8 in there. These are all number 12. I've got a couple of different fittings up here. This is just a 2-inch Romex connector, and I'm about to bring a feeder into here to feed this. And the rest of these are all Romex connectors. There's one up here that you'll notice is different. This is a butterfly style connector, and this thing is actually rated to have 3 pieces of 12-2 Romex in here, where these are all only rated to have 2 pieces in there. So I'm going to talk about that a little bit more in a bit. But this is the deal. I'm going to wire everything, kind of show how I do my panels and try to keep them really, really neat, because I think it's important that y'all do that as well. All right, so I think it's really important before we get into ripping all this out for you to understand my logic and how I lay panels out. I think a lot of people get this wrong. So it's really helpful. What I like to do is I separate things where they come in, and I try to keep them separated the whole time. So you'll notice this is really clean and neat, right? I have all of my arc fault and dual function stuff on one side, and I put all my arc fault and dual function breakers on one side, and that's less room over here. So I just try to keep everything that's doing that in one area. And then I usually stack all of my 220s on one side, and then I will put any other breakers that are non-arc fault in as well. So I like to, when a panel cover is on, I like very similar things next to similar things. So I like to put all my arc faults together, and then I put all my dual functions together. I don't just stagger random stuff throughout the panel. It just looks much cleaner when you've got a panel cover on. So this is 2-pole everything, and then I've just got some extra breakers over here that are non-arc fault. So I'm keeping anything non-arc fault on this side and anything 220 on this side. Now I am realizing that I did put these on this side, but I didn't want the pigtails also over here blocking all of this with all of this other arc fault stuff. So I'm just, in my mind, when I start doing this, I'm like, where is all of my room and what do I need to separate? So I've got all my 220s, my non-arc fault, and all of my arc fault. And I also try to stick to the very back row. And you'll see here, like I had to kind of move some things under other things. We're just limited on where the holes are already. So, you know, to try to make this as clean as possible, I always put all of my staples together in one line. I try to keep everything really nice and straight when I come down, but if I do have to stack, I'm just cognizant of which one goes in front and which one goes in back. So I just think trying to be as clean as possible is really, really important. Now, let's get into the actual wiring. All right, so first thing you might notice is I got these little curly Q things. I just put these on because a lot of times in a panel room, I've just got my wires sticking out, so I like to keep them organized with that. I just take a piece of wire and wrap it around it a few times. I think it just keeps everything a lot neater. And we've always got these extra little bits of wire. Anytime we're working in panels, we have tons of little scrap, so I just like to reutilize the scrap for that. So first thing I'm going to do is start cutting off the sheathing. I'm very, very lightly scoring each one of these and then just pulling them off. Another thing I like to do is just to keep my wires all separated, I throw a nail up. Just kind of helps keep everything clean and out of your way. Now as I'm scoring this, I'm being very, very light with my knife because I don't want to dig into any of the conductors underneath. So you don't want to gouge this and dig really deep. You just want to barely, with a fresh, brand new knife, just guide your knife gently down it. So you might be wondering what I'm doing right now. So a lot of this is going to get cut off, you know, once I start bending them in and putting them on things. But I just like my wire to be as straight as possible. And even when I'm running wires, I don't run and kink and like force wires into things. I like to run in arcs and real like soft and gentle. If I'm having problems pulling on something, I go get someone else to help me because I just don't want to be jamming and like breaking things and messing up the insulation. So just kind of wire management, as I've started to do this over the years, just keeping everything really straight and neat and pretty. Just makes your stuff look a lot nicer. All right, so now that I got all the insulation ripped off of all of my home runs, I'm gonna deal with these pigtails next because I want them to be in the back. I want them out of the way. So I usually take a screwdriver and I go inside of this thing and I pull out towards me. And a lot of people over the years have been like, oh, you can't cut those off, you can't cut them short. That's not true. I've actually spoken to all of the manufacturers of breakers and all of them say the same thing. They just give you enough to be able to reach the top of the panel, but it is absolutely okay for you to cut these off. So I'm going to. And I like to, rather than leaving a whole bunch of this back there and being in the way, I like to run them really short. A lot of people are like, don't do that, you want to leave extra in case you got to move the breaker around. Well, this is a test environment. This is my place and I know I'm not going to. So I'm going to cut that really short. You'll notice too that I'm using the back row first. These neutrals, we actually have a front row and a back row, and I always like to fill up my back row first and leave my, the front row open if I need anything. All right, next thing that we do is I'm going to deal with all of my grounds first. I want the grounds all the way in the back, out of the way. And then I'll deal with my neutrals. I like to fold all of my grounds so that they go all the way back in that corner back there. And then if you notice too, I put my ground bus on the bottom rather than putting it on the sides. Again, I just want a clear chase for all my conductors. I don't want to be busting my knuckles in there and trying to manage all of the grounds back there. So I like to run everything underneath here. Now you'll probably see that I'm putting these Ty-Raps on conductors. This is just something that I like to do. There's this tool, actually these Ty-Raps and this tool are made by ABB. And look at that, it immediately cuts off. It's from the front, so if I have to get into a tight space to cut something off rather than trying to get my diagonal pliers and like reach in, it's just an easier tool. And the best thing is, it's smooth. So like no more reaching in panels and getting cut because you've got some sharp edge that you try cutting with diagonal pliers. This thing's really cool too. So if you take and put it around something, you don't even have to get it all the way tight. You just stick this in and it does all the tightening for you. So it both tightens and cuts at the same time. And then it's smooth. I can run my hand across that, no blood. What I love about these type though, this is specifically designed for supporting and strapping electrical conductors. So in code it says, right, we can't just use random stuff. We have to use things that are listed and rated to be used with electrical conductors. And these are. What's cool about them is they have like a specific kind of grippiness on the backside. They don't just have the little like ratchety pieces of plastic. And then the tongue on the inside is metallic. It's actually like a metal flap rather than this being a plastic flap. So if I wanted to try to take this and break it, it's gonna be really hard to do. It is possible, but I'm pulling with all my might and I can't get it to come out. But if I take this, which is just some generic off-brand that I bought, the clicky one, barely anything. So that is why it's important to be using them in electrical environments, because they're actually listed for this use and it's code, so you gotta do it anyways. So when we put Romex into a panel, we need to be cognizant of how many of these we're putting into each connector. Some people will just try to slap as many of these as they can fit inside of this connector, but each one of these is actually rated for a certain number of pieces of Romex in it. If you notice, this one looks weird, right? It doesn't have a lock ring on it. This is a butterfly style. These only have 2 conductors in them, but I have 3 in this connector. And that's because this one is listed to have 3 pieces of 12-2 in it, where these are not. So instead of failing your inspections and having 3 conductors stuck into one of these, just get one of these because it allows you one more conductor, especially when you've got rows of conductors, right? If you got like 30 home runs that you're trying to stick in here, putting 3 in every single one will save you so much space rather than having to have 2 in every hole and then you run out of holes. All right, so I know there's several of you right now, they're like, why didn't he put his feeder in or his sub feed in before he started doing all of that? And the reason is I wanted to actually show y'all what I do with my sub feeds. I don't use those huge staples that a lot of y'all use. I use small staples for these small conductors because I've got flat cables and they sit down flat with the cables, but I've got a round, huge conductor. So I want something that's round to secure it, and I want something that's really, really strong. And I find that using Ty-Raps actually achieves that. So what I do, and I have to put a disclosure, I've never failed an inspection doing it this way because I'm using 2 different listed devices, and most inspectors that see it are like, holy crap, I've never seen anybody do that before. So judge me all you want, but this is what I do. So the first thing, I'm gonna have this feeder come right down the center, right? What I'm gonna do is I'm gonna take 2 staples and put them vertically, kind of close together, and then I'm gonna stick Ty-Raps underneath that so that they secure to the conductor. I don't go all the way down, I leave a little bit of a gap behind it. All right, so I've got those 2. Now this is gonna go right over the top of that. I make sure that I don't go out too far because I don't want the Ty-Rap to be way out here forming a triangle around it. I want it to suck all the way around this whole thing. So now I go in, figure out what my depth is gonna be. I gotta get all the way down to my ground down there. All right, so I've got that lined up where it needs to be. I'm just gonna tighten it so it doesn't move. Next, I take 2 Ty-Raps. I go through both of those staples. We put it just barely snug. Try to get them both lined up. Just again, kind of aesthetically pleasing. Tighten and cut. tighten and cut. Now that is solid. It is not going anywhere. And to further drive the point home, I'm going to do the same thing here, strapping all the way down a wall. But with these, I'm going to use a little bit thicker ties. So they have them that are twice as thick as well. ABB, it's the same brand from Ty-Rap, but they also have a different tool for these as well. So these heads can come off, but this head is specifically used for these thicker straps. So on something like this that I've got a feeder, you know, it's a lot heavier, and depending on what size feeder, I might have like 4/0 aluminum, you know, I might have something that's really, really thick. So something like this, I'm going to use these thicker ties. Now that we've got that on there, this thing is solid, like it is not coming off. So I just like that because I feel like it's a better securement and it's not smashing down on the conductor like a flat, huge staple is going to be. Plus, you don't just have to sit there wailing on it. You know, this is just, I think, a little bit more finesse way of dealing with the conductor that has a very, very strong hold. So seriously, Ty-Raps, these are listed to be used for this. There's a link in the description below. ABB sells, like, they have tons of different colors, any kind of color environment that you're in. They've got multiple different lengths. Some of them are wider, some of them are thinner, and they've even got tools to install them. I love having this on me, and it's such a simple thing to carry around, and I've got tons of these. I got like thousands of these things. Click the link in the description below. If you're interested in more, check out ABB Ty-Raps. Are you a super nerd electrician like me, where you like reading books and talking about theory and all watching videos and stuff like that? You should become a member of electricianu.com. So membership has a few different benefits. You get all practice exams that we make for free. We've got a residential wireman, a journeyman, and a master. We also have a thing called the Code Cannon, which is 300 questions, and it's not timed, it's self-paced. Take it as many times as you want. And for all of our members, every single month we put out new premium content. So a lot of videos like this that do not get put on YouTube, they're just private for our members. And then we have courses that we drop every month. So every single month we have some new course. It could be transformers, motors, motor controls, calculations, all kinds of stuff, but they're self-paced, so you can kind of go through them whenever you want. So if you're interested in nerding out like I do, check out the link in the description below where it says membership and come join us. Did you know that most of the time when people put NOALOX on aluminum conductors, which is an anti-oxidizing paste, most people don't use it right. So in code, we're supposed to do things according to the manufacturer's instruction, always, right? That trumps everything. On the back of this, it actually says coat the wires with the compound and work in with an emery cloth or a wire brush. How many of y'all are actually doing that? Then number 2, fill the contact surface of the connector with the compound and apply per connector manufacturer's instructions. And number 3, wipe off the excess material from the insulation. So I take a toothbrush because I don't want to do a wire brush, and I go with the grain. And then I take a little bit of extra and I make sure the inside of the connector or terminal is fully coated. And I stick it in there. And right now I'm just hand tightening, but I'm going to go take my torque wrench here in a minute and actually get them tightened to torque. That's how you should be using NOALOX. So now you know. So now that we've got everything torqued to spec, one thing you need to do is go and actually draw a line across each one of these. Some people just do like one line in one place like that. I like to do it in two, because if the thing ever gets turned around, you know, even if one of the lines still lines up, you know that it's like a quarter turn off. A lot of the inspectors are gonna look for this too. They're just gonna look for lines to make sure that you did mark your lugs. So that just lets you know too that everything has been torqued, and if you ever see that those are not in the right place and you know you put the panel in, somebody's been messing with your stuff and now your torque settings are off. All right, so let's talk about, now that we've got this whole thing done, what are some things that you might fail an inspection on when you have an inspector come through to check all your work? First thing, we gotta put these things on. They just protect, it's almost like a dead front so that nobody can come in contact with these lugs. Like we just talked about, you want to make sure that you've got torque settings on all of your lugs. A lot of inspectors have been looking for that lately. You want to make sure that there are no loose lugs anywhere on this. So every single termination that you put in, it doesn't hurt you to just go through real quick before you leave and make sure everything that you did, you try to put a little bit of a turn on, because you would be surprised how often you just forgot like one lug on something. So going through and just kind of touching each one of these does not take you very long. You can do this whole panel in 30 seconds. Just make sure that you got everything tight. Oop, right there. There was one that was a little loose. And I just try to touch each one of these two. Now, I mean, if you're thorough enough when you first go through and you verify each one of these things on every single one of them, that's fine. But most of us get in a hurry when we're out in the field and we just start kind of ripping, and every single one of these holes, you look how many holes there are. After a while, you might have just thought you were in the wrong one, and just stuff happens, you know, we're human. So it doesn't hurt for you to go back and check your work. I highly recommend that you do, because it's gonna save you a service call, and your boss is gonna be super pissed if you get a call, or if they get a call saying, hey, there's some, like our lights keep flickering, going on, going off, and I hear this, I feel this like weird burning smell. Probably because one of these is just sitting in there, you know? So make sure that everything is tight. If you have a loose termination, it can actually create heating so bad because there's not enough of a connection, a solid connection. Now you have a point where you barely have any contact. Instead of a full thing like this, you have like barely any contact. So you can create arcing in there, which can create an incredible amount of heat and end up melting the plastic. You can destroy buses. So just make sure, again, everything is super tight. Make sure that all of the grounding is correct. Like proper grounding and bonding is huge. The inspectors are always checking grounding. Make sure that you don't have a green screw put in here if this is not a service panel. If this is a sub panel, do not put that green ground screw in any of your sub panels. But if this is a service panel you're doing, make sure that green ground screw is in there. Or if you don't have a QO panel, you have to have some kind of means of bonding your neutrals and your grounds. Make sure that on your ground bus, you only have grounds. Make sure on your neutral bus, you only have neutrals. Make sure you're not double lugging. If you have two neutral conductors and you're putting them under one hole, you can't do that. None of these are rated for two conductors. They're actually listed and rated for one conductor each. So make sure you're not doubling up on that kind of stuff. Make sure that you have a bushing. If you've got 4 AWG or larger conductors, these are 2/0 aluminum, so we definitely have to have a bushing on that. I've seen a lot of people fail. Or if they accidentally break the bushing and they still try to hide it and like slide the cut part all the way around to the back. Inspectors are smart. They will figure stuff like that out. Make sure that the number of conductors that you have in each one of these Romex connectors is not, you know, exceeding what the listing is for. Make sure that every one of the screws that hold the Romex connector in place are all the way tight. Make sure that your lock rings are all the way tight. Oh, there we go. I got one that's just a little bit loose. You're basically just double checking all of your work and making sure that you didn't leave anything out. Next, make sure that you are stapled within 12 inches of the enclosure. You know, make sure that these things are secure and they're not going to get pulled out. And make sure that you have a nail plate. All of your feeders up here. You'll notice that this one I got drilled out way close. It's because I got that stud up there, so I couldn't drill any further back. But that doesn't matter because I put a nail plate there, so there's no way a nail is going to get driven into that thing. Once the drywall people go up and put the drywall on. The other thing too is make sure that you're no more than 6'6" to the highest handle, which this is the highest handle. People need to be able to reach to turn that main off. So if you got a panel where the breaker's like way up here, you know, it's way too high. So make sure that you're not more than 6'6" for that. Oh, and then one more thing, make sure that you at least have a 1/4 inch of sheathing sticking out of each one of these. You can't just have conductors going up through a fitting. You actually have to have the sheathing coming out. So at least a 1/4 inch there. Another thing I see some people fail for is not knowing what is supposed to be on arc fault and what's supposed to be on dual function, ground fault, things like that. So I like to put these little tags on just for, I mean, for my ease when I take the panel cover off and it's sitting on the ground. I mean, it's dummy, you know, I've got it all right here. It's pretty easy to see what everything is, but it also helps an inspector to walk through and be like, okay, I've obviously labeled every single one of those so he can easily see which one are my arc faults, which one are my dual function, what's not. So he can see like, oh, this was supposed to be arc fault and you didn't put it on there, you know? So it just kind of shows the confidence a little bit that you know which one, what every single one of these is for. You hooked them all up right. And I think something that is that clean, that just looks really pretty, that's done well, that a lot of care is taken and doesn't have any code violations in it, I think that shows an inspector like, I don't have to worry about this guy so much. He's probably all right. I'm gonna sail through here and just make sure there's no obvious crazy stuff. So, hope that helps y'all. Leave some comments below. Obviously, this is not a stacked panel. If I had, you know, this whole thing full, way more wires, it would have been way more complex and a lot harder to fit all of this stuff in there, but it still would have been pretty much the same way. So if there's anything else that y'all want to see, any other different like panels, commercial panels, stuff like that, just let me know in the comments. Love you crazy people. I'll see you in the next one.